Q7253. Fuel enters a two-cycle engine through an A. Intake port and intake valve. B. Intake port and reed valve. C. Intake valve and reed valve. The correct answer is A. Fuel enters a two-cycle engine through an intake port and intake valve. In a two-cycle engine, fuel and air are mixed together in the crankcase before being transferred into the combustion chamber. The intake port is an opening in the cylinder wall that connects the crankcase to the combustion chamber. Through the intake port, the fuel-air mixture is drawn into the combustion chamber during the engine's intake stroke. The intake valve controls the flow of the fuel-air mixture into the combustion chamber. It opens during the intake stroke to allow the mixture to enter the chamber and then closes during the compression and power strokes to seal the combustion chamber. 7254. The first indication of carburetor ice in an aircraft with a four-cycle engine and fixed-pitch propeller is A. An increase in RPM. B. A decrease in RPM. C. A decrease in oil pressure. The correct answer is B. The first indication of carburetor ice in an aircraft with a four-cycle engine and fixed-pitch propeller is a decrease in RPM. Carburetor ice can form when the temperature and moisture conditions are right, and it can restrict or block the flow of air and fuel into the engine. In a four-cycle engine, the carburetor is responsible for mixing the air and fuel before they enter the combustion chamber. When carburetor ice starts to form, it restricts the airflow and disrupts the proper air-fuel mixture, resulting in a reduction of engine power. As a consequence, the engine RPM, revolutions per minute, will decrease. This decrease in RPM is the first indication that carburetor ice may be present. The first indication of carburetor ice in an aircraft with a four-cycle engine and fixed-pitch propeller is a decrease in RPM. This reduction in RPM is a result of the airflow disruption caused by carburetor ice, leading to a less efficient combustion process and a decrease in engine power output. 7256. Coolant in a liquid-cooled engine is normally circulated by A. Capillary attraction. B. An electric pump. C. An engine-driven pump. The correct answer is C. Coolant in a liquid-cooled engine is normally circulated by an engine-driven pump. Liquid-cooled engines use a cooling system that consists of a radiator, coolant, and a pump to regulate engine temperature. The coolant, which is a mixture of water and antifreeze, circulates through the engine and absorbs heat generated by the combustion process. An engine-driven pump is responsible for circulating the coolant. The pump is typically driven by a belt connected to the engine's crankshaft. As the engine runs, the pump rotates and creates the necessary pressure to move the coolant through the engine and radiator. 6482. High EGT on a two-cycle engine could be caused by A. High oil temperature and low oil pressure. B. Pre-ignition, detonation, or an air intake leak. C. Improper engine operation. The correct answer is C. High EGT, exhaust gas temperature, on a two-cycle engine could be caused by improper engine operation. EGT is a measure of the temperature of the exhaust gases exiting the engine. It is an important parameter that indicates the combustion efficiency and overall engine performance. When the EGT is higher than normal, it suggests that the engine is operating at a higher temperature than desired. Improper engine operation can cause high EGT. Several factors can contribute to this condition, such as incorrect fuel mixture, improper carburetor settings, excessive engine load, or inadequate cooling. These issues can result in incomplete combustion, inefficient fuel burn, or excessive heat buildup in the engine, leading to elevated EGT readings. In summary, high EGT on a two-cycle engine is most likely caused by improper engine operation. Factors such as incorrect fuel mixture, carburetor settings, engine load, or inadequate cooling can contribute to elevated EGT readings. Monitoring and addressing these issues are important to maintain proper engine performance and prevent potential damage due to excessive heat. Q7257. In order to improve engine efficiency, two-cycle engine exhaust systems are tuned to A. Close the exhaust valve to stop the fuel mixture from exiting the cylinder. B. Stop the fuel mixture from exiting the cylinder before combustion. C. Use a reed valve to stop the fuel mixture from exiting the cylinder. The correct answer is B. In order to improve engine efficiency, two-cycle engine exhaust systems are tuned to stop the fuel mixture from exiting the cylinder before combustion. The exhaust systems of two-cycle engines are designed to prevent the fuel mixture from exiting the cylinder before combustion occurs. This is achieved through careful tuning of the exhaust system components. In a two-cycle engine, the combustion process occurs during the upward stroke of the piston as it compresses the fuel-air mixture. Unlike four-cycle engines, two-cycle engines do not have a separate exhaust stroke. Instead, the exhaust gases are expelled from the cylinder and fresh fuel mixture enters in the same stroke. The exhaust system of a two-cycle engine consists of various components, including the exhaust pipe, expansion chamber, and sometimes a muffler or silencer. These components are designed to create a tuned exhaust system that helps improve engine performance by optimizing the flow of exhaust gases. By tuning the exhaust system, engineers aim to achieve specific pressure waves and gas flow characteristics that enhance scavenging. Scavenging is the process of removing exhaust gases from the cylinder and replacing them with fresh fuel-air mixture. The goal is to minimize the loss of fresh mixture through the exhaust port before combustion occurs. By preventing the premature exit of the fuel mixture, the tuned exhaust system helps improve the overall efficiency of the engine. It ensures that a larger portion of the fuel-air mixture is utilized for combustion, leading to improved power output and performance. In summary, two-cycle engine exhaust systems are tuned to stop the fuel mixture from exiting the cylinder before combustion. The design and tuning of the exhaust system aim to optimize scavenging and improve engine efficiency by maximizing the utilization of the fuel-air mixture.